I'm Alan Trimpton, I'm from Bournville Village Trust. Welcome to our Eco Demonstration House. This is something we undertook in 2007 in order to showcase what could be done to older properties. There's been lots of work done on new properties, but very little done on older properties, how they can be improved energy-wise and their sustainability. All the insulation in the house has been improved, especially in the roof space, and because there's a 9-inch solid wall, we've incorporated external insulation. Here, 100mm, about 4 inches. This is the latest thinking in sustainable timber windows, factory finished, guaranteed for 35 years, double glazed of course, and with energy saving glass. This is the inside of the window, and then to improve the insulation still further, we've got a 40mm phenolic insulation board on all of the external walls. We're now at the rear of the house, and working down from the top you can see the solar panels on the roof. We've also got the rainwater pipes, all of which are recycled steel. We've got the passive air vent system. There's the sun pipes are visible, or just visible, and then on the kitchen extension there's the sedum roof. Here we can see the kitchen extension with the top of the sun pipe and also the sedum roof. Now, the sedum is a most interesting desert found succulent, and it serves several purposes. It's improving the insulation of the roof. It also holds water when it rains and only allows it off more slowly, and then is actually quite good from a biodiversity point of view. We're in the kitchen, and this showcases several things. Firstly, we've got the sun pipe, and on a day like this is all the natural light you need. If you do need artificial lighting, of course they're compact fluorescents. All the appliances here are A-rated at least, or above. All the kitchen units are made from recycled timber. We sought to try and reduce the air leakage from the house, but in the bathroom and here in the kitchen it's necessary to get stale or damp air out, and what we've used is a passive vent system. Absolutely no electricity used at all. It works itself just by air temperature in here and outside and the wind out. This is the head end of the ground source heat pump. There's a borehole 65 metres down into the ground, and there's a pipe goes down and back out again to the heat exchanger in the rear of the house. This is the technical end of the ground source heat pump, and we saw in the front of the house the borehole, and what happens is that water from this system is pumped down into the ground, and when it comes out again it's gained some heat from the ground. There's a heat exchanger in here that increases the temperature of that, and that's then used to heat the whole house, the central heating, and part of the hot water. The rest of the hot water comes from here, which is linked to the solar panels that are on the roof. The heat from the ground source heat pump for the central heating comes through and under this floor. This is a ceramic floor, and you've got 3 zones in order to control the temperature: the lounge, the dining area and the kitchen. We've also used the latest thinking in smokeless fuels, multi-purpose, burning coal or timber, and it's nice to sit round. It is needed perhaps in the very depths of the winter. The lighting in the dining area are light emitting diodes. They're simply 2.5 watts each, compared with say 20 in a compact fluorescent. Now the house is finished, we have it occupied. When it was open to the public we had over 1,000 people in here, and now it's occupied. We're monitoring both this house and a control property. All the results will be published and also feed through into our own modernisation programme.